Alright, this video is for the Blended Algebra 2 class. We are working on Unit 3, which is solving quadratics. This is the review of the grouping factoring method. So that's the third method we're going to do here. Again, the first blank is saying that the third method we're going to talk about is factoring by grouping. Now, grouping is special because it only is able to be used when you have 4 terms. Okay, so we've done GCF where it didn't matter the number of terms. We did difference of squares, where you can only factor using 2 terms. Grouping can only be used 4. Another reminder, you must always remember to look and take out a GCF first before you factor anything else. So we're going to start by factoring this guy completely. Remember, grouping is only used with 4 terms. Let me show you what that means. It means we have 1, 2, 3, 4 terms that are separated by plus and minus signs. When I factor by grouping, the process is like this. We're going to put the first 2 terms in parentheses and the last 2 terms in parentheses. Now, from each of those terms, we are looking for a GCF. So when I look at x cubed and 2x squared, I should notice that these 2 terms have an x squared in common. Now, I'm only working with the first set of parentheses to start. Because I'm dividing out x squared, I'm going to pull the x squared out in front of my set of parentheses. I'm going to divide x cubed divided by x squared. I subtract the exponents, 3 minus 2, to get x. 2x squared divided by x squared is 2. Now, I'm done with the left side for now. Let's look at the parentheses on the right. I have positive 5 and 10. The number that they have in common is 5, not x, because the 10 doesn't have an x. So I pulled out a positive 5, so I'm going to make sure I put a plus 5 in front of my second set of parentheses. 5x divided by 5 gives me x, and 10 divided by 5 gives me 2. Now you should notice something here. You should see that inside the parentheses, you have the same thing, x plus 2. That's a good thing. That tells you that you're factoring correctly. However, this is not your final step. Your final factored form is going to be 2 binomials. Firstly, you pull down what's in the parentheses. That goes into one set. The other set of parentheses pulls the GCFs you used, which are going to be x squared plus 5. This is now your final factored form. So let's try another one. Number 2. First, we look for a GCF. We have 5, 20, 3, and 12. There's nothing that those numbers have in common, so there's no GCF for the whole problem. So I'm going to start by grouping the first set and the second set. From the first set on the left here, I look for a greatest common factor. 5 and negative 20 both have a 5 in common. And x cubed and x squared, I pull out the smaller exponent, which is x squared. Once I find that GCF, I put that GCF in front of my set of parentheses. The 5 divided by 5 cancels each other off. X cubed divided by x squared is just x. All right, now negative 20 divided by 5 is negative 4, and the x squares cancel off there. So that's the first side. Let's look for the GCF of the second set. 3 and negative 12. Well, they both have a 3 in common, so that's going to be my GCF here. I'm going to write the positive 3 in front. 3x divided by 3 is just x. Negative 12 divided by 3 is negative 4. Now, just like the last problem, I had 2x minus 4. So that's a good thing. That x minus 4 is going to come down into one of your binomials in your answer. The other set of parentheses gets the GCFs from in front. 5x squared plus 3. And that would be your final factored form. All right, number 3. Again, I start by looking for a GCF. X cubed, 2x squared, negative 3x, and negative 6. There is no number that goes into all of those, no variable. So I go ahead and start with grouping. I group my first terms and my second term. From the first group, x cubed into x squared. There's no number that goes into both, but it looks like I can pull out a variable. I take the variable with the lower exponent, which is x squared. I pull the x squared out in front. And remember, you subtract exponents, so 3 minus 2 is 1. I'll just have a plain x inside. Here the x squares are going to cancel off, but I will have a plus 2. Now this time, when I look at negative 3x minus 6, I'm going to pull out a GCF. Now, you would say it is 3 here. However, if this sign on the third term is negative, you need to pull out a negative GCF. That's the only time you'll pull out a negative GCF, is if this third term is negative. So when I pull out the negative GCF there, the negative 3's cancel, and you're left with positive x. Negative 6 divided by negative 3 is positive 2, which works out because my x plus 2 show up twice. So that x plus 2 is one factor, and the GCFs from the front, x squared minus 3, become your other factors. So that is your final factored form. All right, number 4, 15x cubed minus 25x squared minus 18x plus 30. I look for a GCF, 15, 25, 18, and 30. It doesn't look like it. Nothing goes into all 4 of those numbers. So I'm going to group here. First 2 and the last 2. Now when I pull out a GCF in the first set, it looks like they both have a 5 in common. And they both have x's, so I'm going to pull out an x squared because that's the lower exponent. My 5x squared comes in front. 15 divided by 5 is 3. X cubed divided by x squared, I take 3 minus 2 is 1. On the next part, negative 25 divided by 5, I subtract 5, and these x squares cancel. On this side, notice again, I'm starting with a negative, which means my GCF is going to be negative. Negative 18 and 30 both have a negative 6 in common. There's no variable because the 30 doesn't have an x. So when I pull out a negative 6, a negative divided by a negative here is going to be a positive 3x, but positive divided by negative 6 is going to be minus 5. And those parentheses are the same, so those come down, 3x minus 5, and the other set of parentheses takes what was in front, 5x squared minus 6. And that's your final answer. All right, we have a couple more here. Then we'll get to some practice. 18x cubed minus 9x squared plus 18x minus 9. I look for a GCF to start. And you should notice that all those terms have a 9 in them. So before we even start, we need to remove our GCF of 9. So I'm going to pull the 9 out. I'm going to use square brackets. You could use parentheses if you wanted. I'm going to pull the 9 out. And I'm left with here 2x cubed minus 1, or just minus x squared. Here I have plus 2x. And remember, anything divided by itself in this last term is going to be minus 1. Now, that 9 GCF needs to stay in front. But otherwise, we're going to jump into the method of grouping. So I'm going to keep that 9 hanging out, but otherwise I'm just going to group the rest of the way like normal. So I look for a GCF of this first set. There's no number here, but I can pull an x squared out of both. So again, I'm going to keep that 9 in front. Just ignore it, but let it stay there. Now I'm going to pull my x squared in front of my parentheses. 2x cubed divided by x squared, I have 2. And those x's simplify to be an x. I don't know why I have that one there. 2x. And then here, the x squares cancel off, so I have minus 1. All right, now my GCF on the next one, 2 and negative 1. The only number that goes into both is 1, which normally we don't pull out as a GCF, but in the method of grouping, we do pull out a 1. And we're going to pull out a positive 1 because the sign is positive. So I'm going to pull out a positive 1, and I will have inside parentheses 2x minus 1 when I divide. Now your final answer here, you bring that 9 down. Still your GCF. And then you have two other binomials. All right, we have 2x minus 1, shut up twice, so that's one of my parentheses. And then the GCFs from in front, x squared plus 1. That entire thing is the final factored form. All right, we have one more on our notes here. 3x cubed minus 15x squared plus 2xy minus 10y. Doesn't look like there's a GCF. They don't all have the same variables, and the numbers 3, 15, 2, 10 don't have a number that goes into all of them. So we'll start with grouping. The first group, 3x cubed minus 15x squared. Looks like they both have a 3, and they both have x's. So I'm going to pull out x squared because that's the smaller of the two. So I'll pull out a 3x squared. And when I divide that, the 3's cancel off, and x cubed divided by x squared is just x. Negative 15 divided by 3 is negative 5, and here the x squares cancel off. All right, in my next set, I have a 2, the number 2 in both, and they both have the letter y. So I'm going to pull out a 2y, positive 2y, as my GCF. Right here, the 2's cancel, the x stays, the y's cancel. Negative 10 divided by 2 is negative 5, and these y's cancel. So again, we know it's good because x minus 5 is in both. So my final answer has an x minus 5, and then these GCFs, 3x squared plus 2y. That'll be your final answer. Remember, you are allowed to check your work. If you check your work, you're going to use the distributive property. So let's just do one here. X times 3x squared is 3x cubed. X times 2y is plus 2xy. Negative 5 times 3x squared, negative 15x squared, and then minus 10y. Now that is actually the same as what you started with. These middle terms are in a different order, but they're the same signs, so we know that we factored correctly. All right, there's your notes on grouping. There will be 2 short practice videos. If you have questions on those, ask your teacher or check the keys that are on Canvas.